Welcome to lesson P4, so our fourth pre-lesson before we get back into topic one. We're going to be talking about absolute value equations. The objective here is also mentioning absolute value inequalities, and that'll be, we'll do that tomorrow. Okay, so we're going to focus on equations today, inequalities tomorrow. Let's first start with the definition. The absolute value of a number is defined as its distance from zero on a number line. That's why when you think of absolute value in practice, you think of it as a positive number. Well, a distance has to be a positive number. If you look at the algebraic definition of absolute value, for an x value greater than or equal to 0, its absolute value is itself. So for instance, the absolute value of 3 is 3, and the reason is because 3 is 3 away from 0 on a number line. If x is less than 0, so a negative number, its absolute value is its opposite. So for instance, if you had negative 3, it's a number less than 0, its absolute value would be the opposite of negative 3, which is positive 3, because negative 3's distance from 0 on a number line is 3. And this also is why the absolute value of a number is always positive, right? If it's positive, it stays positive. If it's negative, it turns positive, okay? Now let's look at absolute value in the context of an equation. Well, what are the values of j that could equal 25 in this equation? Well, j could equal 25 or negative 25, because the absolute value of 25 is 25. The absolute value of negative 25 is also 25. So there's two different scenarios there. You don't know which one is true, so j could equal either of those. When I look at this equation that has a variable in it, you have two different options. So option number one, what's inside is positive. So you have 15 minus 3x is equal to 6. The other scenario is you assume what's in there is negative. So you have 15 minus 3x is equal to the opposite of what's on the outside, so negative 6. And then we'll just solve both those equations to get two separate answers. Here we'll subtract negative 15, we'll subtract 15. And you get negative 3x is equal to negative 9. Divide both sides by negative 3, and you get x is equal to 3. Right, over here, you subtract 15, and you get negative 3x is equal to negative 21. Divide both sides by negative 3, and you get x is equal to 7. So in this case, you could say x is equal to 3 or 7. Okay. Let's try the exact same thing here. Again, if I assume what's inside the absolute value bar is positive, then it's equal to 7. If I assume what's inside the absolute value bars is negative, then its absolute value is the opposite of 7, so negative 7. And then we'll just solve each of those separately. So the first one will subtract 2, and you get 3x is equal to 5. So that means when you divide by 3, you get x is equal to 5/3. And there's no reason to make that a decimal or a mixed number. Leaving it as improper fraction is totally fine. Over here, we're going to subtract 2 on both sides. So then 3x is equal to negative 9. Divide both sides by 3, and you get x is equal to negative 3. So you can say x is equal to negative 3 or 5/3. All right, if the equation has extra stuff, you got to isolate the absolute value first. So that's just to say the absolute value of x plus 9 has to be isolated. It has to be by itself before we can split it into two equations to solve. So there's two things happening here. That 4 is a positive 4, and it's adding to the absolute value. That -2 is multiplying. We're going to undo, get rid of that extra stuff in the opposite order of order of operations. So the first thing we're going to do is subtract 4 from both sides. And now I have -2 times absolute value of x plus 9 is equal to -9. Then I'm going to divide both sides by -2. And I get absolute value of x plus 9 is equal to 9/2. Now I can split it. If you try to split it before you get rid of that 2, get rid of that 4, it's not going to work. Okay, so now I can split it into two different equations. If I assume what's inside is positive, you get x plus 9 is equal to 9/2. If I assume what's inside is negative, x plus 9 is equal to its opposite, so -9/2. Okay. Now if I subtract 9 from both sides, I get x is equal to -9 plus 9/2. I'm going to convert -9 into a fraction over 2. So if you think about it as a fraction over 1, multiply both the -9 and the 1 by 2. Now I've got x is equal to -18 over 2 plus 9/2. Now when I add -18 plus 9, you get -9. And it's over that denominator of 2. Okay. Same thing over here. We're going to subtract 9 from both sides. You get x is equal to -9 minus 9/2. We'll do the same thing. Think of it as a fraction over 1. Multiply the -9 and the 1 by 2. So now you have x is equal to -18 over 2 minus 9/2. And then that's equal to -27/2. Right? So then you can say x is equal to -27/2 or -9/2. Okay, so same job, just took some work with fractions there as the last example. This one, same deal. You got to get rid of the 5 and the 2. We're going to get rid of the 5 first. So I get rid of the 5 first. Subtract 5 from the sides. Now I get 2 times the absolute value of 3x minus 1 is equal to 28. Divide both sides by 2. You get an absolute value of 3x minus 1 equal to 14. Now we can split it. If I assume what's inside is positive, 3x minus 1 is then equal to 14. If I assume what's inside is negative, 3x minus 1 is equal to -14. If I add, now I'm just going to solve each one separately. I'm going to add 1. Then I get 3x is equal to 15. Divide by 3. You get x is equal to 5. Add 1 to both sides. You get 3x is equal to -13. Divide both sides by 3, and you get x is equal to -13 thirds. And again, just leave it as an improper fraction. No need to turn that into a decimal or a mixed number. So then x is equal to -13 thirds or 5. All right, let's look at the next one. Now that I have absolute value of 2x plus 7 equal to negative 2, this is different than everything we've done so far. And there's one big difference, right? And that difference is that negative sign. At the beginning, we talked about the definition of an absolute value, right? The absolute value of something is equal to its distance from 0 on a number line. A distance cannot be a negative number. So you can't start with a negative. I know in the process of solving it, we've set things equal to like the opposite, which ends up being a negative number, and that's fine, but it can't be a negative at this point. So quite simply, when will an absolute value ever give a negative answer? And the answer is never, okay? So if you get something like this one, it's simple. It's just no solution, okay? That can't be, right? The absolute value of 2x plus 7 cannot equal negative 2. So what that means is there is no value of x that will make that true. The whole thing is no solution, right? If you look down at example 3, that might look negative, negative 4x minus 1, but there are values of x that would make that true. So what we don't know at that point, right? So if there's a variable involved on the outside, you have to go through the entire process. What you'll have to do, though, is at the end, you'll have to check. An extraneous solution, as defined here that you're going to copy in your notes, is a solution of an equation derived from the original equation that is not a solution of the original equation, meaning you're going to get solutions when we solve it the way that we just practiced solving it, and it might not work. And it might not work, meaning it'll turn that number to negative once you solve for it. So let's take a look at what happens here. First thing we're going to do is split it, right? So if I assume what's inside is positive, then it's going to be equal to what's on the outside, so negative 4x minus 1. If I assume what's inside is negative, then it's going to be the opposite. So the opposite of both terms. So positive 4x and plus 1 is a negative 1. Now I'm going to solve both. Okay, so I'm going to add 4x to both sides. And I'm going to also add 4 to both sides. Okay, so now I get 7x. That cancels, is equal to 3. So then x is equal to 3/7. Okay, on the right side, let's subtract 4x from both sides. And let's add 4 to both sides. You're going to end up with negative x is equal to, that cancels, 5. So then that means x equals negative 5. Now we're going to check our solutions. And the way you're going to check your solutions is into the expression negative 4x minus 1. It's a bad solution if negative 4x minus 1 ends up being negative, because the absolute value in the original equation can't equal a negative number. So an x value that makes this expression negative would mean that that expression is then negative, and it can't be. So if I take 3/7 and I substitute it in for x, you can do the work. However, what's going to happen is, well, you're going to end up with negative 12/7 minus 1. I can figure out what that actually is. Save yourself a couple seconds, because negative 12/7 is negative, right? If you subtract 1 from it, it gets more negative. So it's negative. And that's all that you care about. I don't actually care about what that number is. I care about whether it's positive or negative. I know that it's a negative number now. So then that means solution of 3/7 is extraneous. Okay? If I substitute negative 5 into that expression, negative 4 times negative 5 minus 1. Negative 4 times negative 5 is positive 20. Minus 1 is 19. 19 is positive. So that means x minus 5 is x equals -5 is a good solution. And in this case, it's the only solution because the 3/7 was extraneous. Okay? I want you to try this one on your own. And then um, I want you to try the practice that is posted. Okay? And I'm here to help. If you have questions before you start, if you have questions after you start, um, please reach out to me in the breakout room. And then tomorrow, the plan is we are going to um, do absolute value inequalities. Okay?